All right, let's dive right in. Today, we're talking about the biggest topic there is, and I mean that literally. We are going on a high speed tour of the universe, from its absolutely mind boggling scale to its deepest, darkest secrets. Let's get started. So, where do you even begin with something this big? Well, let's start with the definition. And this really gets right to the heart of it. The universe is everything. It's not just the stars and the planets we see, but all of space, all matter, all energy, and yep, even time itself. Think of it as the ultimate container. To try and wrap our heads around the scale of it all, let's start with something we all know, the Earth and our moon. Okay, picture this. If the Earth were the size of a soccer ball, the moon would be a cantaloupe, nearly a full basketball court away. Right away, that sheer emptiness of space really starts to sink in. I mean, that's a huge gap just between us and the moon. So it makes you wonder, right? What happens when we zoom out from here, way, way out? And that brings us to our first section, a journey of scale. We're about to take some absolutely massive leaps in perspective to try and understand our tiny, tiny place in the cosmos. So you might want to buckle up. Let's start small, well, cosmically small. A single planet orbiting its star. This is our home base, the very first rung on an impossibly vast cosmic ladder. Now, let's pull the camera back to see our whole solar system. It's a staggering 5.6 billion miles across. And here's the wild part. We now know our star isn't special. There could be billions of other solar systems just in our own galaxy. Suddenly, our home feels incredibly small. Okay, zooming out again, we see our stellar neighborhood. The closest star to us, Proxima Centauri, is over 4 light years away. And within just 50 light years of us, there are about 2,000 other stars. Just like that, our entire vast solar system becomes just another tiny point of light in a crowd. You heard me say light year, right? At these kinds of distances, miles and kilometers just become meaningless. The numbers are too big. So astronomers use a different yardstick. A light year is simply the distance light can travel in 1 year, and that's almost 6 trillion miles. It's really the only way we can talk about these distances without our brains melting. Okay, so we've established that space is big. Really, really big. But what shape is it? I know, that sounds like a weird question, but in this next section, we're going to explore that. And we're going to have to bend reality a little bit to do it. This is a pretty tricky concept, so to make it easier, scientists came up with this brilliant analogy. I want you to imagine that space isn't three-dimensional, but it's like a flat, two-dimensional rubber sheet. Now, the gravity from all the stuff in the universe, the stars, the galaxies, everything, bends and warps the sheet. So, depending on how much stuff is out there, that rubber sheet can bend in a few different ways. If there's enough density, enough gravity, it could curve back on itself into a closed shape, sort of like a sphere. But if it's not dense enough, it might stretch out into an open, saddle-like shape that just goes on forever. But there's a third option, and it's the one most scientists now think is correct. If there's just the right amount of matter, the universe is flat. Now, flat here doesn't mean it's like a piece of paper. It means it's infinite, with no outer edge. It just keeps going forever. All right, so we've got a sense of the scale and a theory about the shape. But what is all this stuff that's bending space-time in the first place? Well, the answer is one of the biggest, and I mean biggest, surprises in all of modern science. Let's just pause for a second and ask that question directly. We see all the bright, shiny things, right? Stars, planets, galaxies. But is that all there is? Is that what the universe is mostly made of? Okay, you might want to brace yourself for this one. This chart just lays out the whole mystery. Everything we know, everything we can see, every star, every galaxy, that's all normal matter, and it makes up only 5% of the entire universe. The rest of it, the other 95%, is made of stuff we can't see at all, dark matter and dark energy. So what is all this invisible stuff even doing? Well, scientists think that dark matter acts like a kind of cosmic glue, providing extra gravity that holds galaxies together. And then there's the even more mysterious dark energy, which seems to be acting like an anti-gravity force, pushing the universe apart faster and faster. Now, what's really fascinating is if we zoom into that tiny 5% slice of normal matter, even that isn't very diverse. It's almost all hydrogen and helium, the two simplest elements in existence. Everything else, carbon, oxygen, iron, you, me, all of that is in that tiny 2% sliver called other elements. And after all that, after you account for the dark energy, the dark matter, and even the normal matter, the universe is still, well, this. It is 99.999999999% empty space. Just a vast, dark, silent void. For our final section, we're going to touch on one of the most truly mind-bending ideas that comes from the universe being so huge. We're going to talk about how our telescopes are, in a very real sense, also time machines. So the key idea here is this. Light, as incredibly fast as it is, doesn't travel instantly. It takes time for it to get from one place to another. So when you look at the sun, you're actually seeing it as it was 8 minutes ago. When you look at a distant star, you could be seeing light from thousands of years in the past.
And this is the stunning result of that fact. This famous image from the Hubble Space Telescope isn't just a picture of distant space, it's a picture of ancient time. The light from some of those faint smudges of light has been traveling for over 13 billion years to reach us. We are literally seeing some of the very first galaxies as they were forming, not long after the dawn of the universe itself.
Which brings us to the age of the universe itself. Our best measurements tell us it all started with an event we call the Big Bang, about 13.8 billion years ago. And that's the ultimate limit. We can't see anything whose light has been traveling for longer than that, for the simple reason that the universe didn't exist yet. And that leaves us with one final, profound question. We can see the edge of the observable universe. That's the bubble of space whose light has had enough time to reach us since the Big Bang. But if the universe really is infinite, what incredible wonders and mysteries lie just beyond that horizon, in the darkness we can't yet see? It's a pretty humbling thought. Thanks for joining me on this journey.